With these binomial distribution questions, there's not really a lot of calculation involved if you know how to use the tables, but it really is a matter of unraveling what is being asked here. So we have in this question, you might want to pause it and read it first, but we have an insecticide that kills 60% of all insects in the experiments. This is also an assumption that for any given insect, there's a 60% chance that if we apply the insecticide, it'll kill that particular. And we have 11 insects in our sample. What's the probability that exactly 5 will survive? So do notice the little trick here is it's killing 60%. So if 5 of the 11 survive, the first thing we have to figure out is exactly how many would need to be killed, and that would be 6. If there's 11 insects, 5 survive, that means we want to know the probability of killing 6 of them if there's a 60% chance of killing any given one. So let's go to the tables. Um, the probabilities is when we want to know an exact number for a specific value. In this case, we want to kill exactly 6. If we want to kill like between 0 and 6, that's when we'd use the cumulative. We'll do that in just a second. Right now, we have exactly, so our n value is 11. In other words, the sample size is 11. The probability of killing any given insect is 0.6, so we're in this column. And we want to know the chance of killing exactly 6 of them. So this is the probability. Again, in plain English, we have 11 bugs. We want to kill exactly 6 of them. That means 5 of them would survive. And the chance of killing any given one is 0.6. So 0.2207 is what we want here. And we need to and paste that value. Now, the next question, so in this case, we have 12 properties. There's a 40% chance of selling any one. So far, this is a very similar problem as before. And we have independent selling, which we assumed in the last one also. Here's where it gets different. Compute the probability of selling more than 3 properties. So we want to know the chance of selling 4 properties, plus the chance of selling 5 properties, plus the chance of selling 6 properties. So there's, and so on, all the way to 12 properties. There's 2 ways we could do that. We could use the chart that we just did. I believe there was 12 there. Should have looked more carefully. I think it said 40% chance of selling any given property. And we want to know the chance of selling, I think it was 4 or more. I'm going to have to look back at the problem. But if so, it would be the chance of selling 4 plus the chance of selling 5 plus the chance of selling 6. And you could add those all the way down to the chance of selling 12, which isn't very high. That's one way to do it, and that would give you a correct answer. The quicker way to do this problem, let me close this table here. So we have 12 properties. We want to sell more than 3. So if we go to the tables and go to the cumulative, again, we go to this n value 12, notice that there's a 22.53% chance of selling. This is a cumulative. So what that means is of selling 0, 1, 2, or 3. So this would be the chance if each one had a 40% chance of success. This cumulative would include this entire range. They've basically taken the probabilities from that other chart and just added them all up. So going 0 through 3 is this right here. And you might say, no, 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 wait, the problem asks for more than 3. So we actually want everything except the situations where she sells 0, 1, 2, or 3. We want the situations where she sells 4, 5, 6, all the way through 12. But the trick here is if this is exactly what we don't want, we want everything except the cases where she sells 0, 1, 2, or 3, we can just subtract this from 1 to get our answer. So we would take 1 minus this, and that would, I think, give us 0.7747. So let's, again, and let's try that out, 0.7747. So the idea of using the cumulative gives you everything up to a certain value. It's really just a shortcut. If you felt uncomfortable with that cumulative idea, you could always use that original table here and just add up everything you wanted. So in that case, we could add up this value, this value, this value, all the way down to 12. It's buried now behind my good job, Daniel. But if you added those up, that would be the same answer that we just got by using the cube. So just use whichever one you're more comfortable with. Okay, this type of problem is essentially the same as that first type of problem, because we want to know an exact value. We just want to know the probability of getting exactly 6 successes out of 18. So we don't have to worry about the cumulative here. We don't want to know 0, 1, 2, 3, 4, 5, 6. All we want to know is exactly 6 out of 18 if each one has a chance of zero point 0.4. So in that case, we would just go to this one. We have 18 items. We want 6 with exactly a chance of zero point 0.4. So that would be this value right here. Each one has a chance of zero point 0.4 and they're independent. Be that. And we need to get rid of our table there. And I'm going to guess, yep, there we go. So there's a cumulative. Now this is exactly like the real estate problem was. So here, we want to know probability x less than or equal to 4. We only have 7 trials. So this here means we don't just want to know the chance of getting 4 out of the 7. We want to know the chance of getting 0, 1, 2, 3, or 4 when each one has a probability of 0.6. So again, we could use that table here. The very first one would use n equals 7, and we would just add the values for the 0, the 1, the 2, 3, and I'm forgetting if it was less than or equal to 4. I think so. That's how we could handle this one here. However, it's going to be much easier if we just use the cumulative, because this one here, if we choose 4, is going to automatically include 0, 1, 2, 3, and 4. I believe that was 0.6 probability for any given one. So this would give us the chance of getting a 0, 1, 2, 3, or 4 if each one had a probability value. And we'll here. So again, these last two that we did were just the symbolic equivalents of those first two that were more word problem context.